the finish chapter 2. I hope today we'll go over the ionic compounds versus covalent compounds. And we went through this last time. We explained to ourselves the physical properties and the chemical properties of some of the characteristics of ionic versus covalent. Now, if you look at this, we'll go through today. I'm recording. I am recording. So please. So, the ionic versus covalent. Ionic versus covalent. And we talked about the ionic is characteristic. They have to have a metal. They have to have a metal combined with one or more nonmetals. The covalent, on the other hand, is coming from the Greek name to share. They are sharing their valence electrons together. They are not, there is no metal inside. So they are combination of nonmetals. That's what we call covalent. So, and we went through the physical properties. That's all inside. We will not repeat this one here. But today, I'm switching sharing to the Microsoft Word. That's where start. Today, I'm starting a new type of writing. I think this way will be much better to type. I think writing. You saw yourself. It's a very sad situation with writing on this Webex with the stylus pen. Although I have stylus pen, but you saw this is not compatible with Webex. Webex took the whiteboard out, so I made myself a whiteboard made of Microsoft Word, and I will type. So you'll see me a little bit slow because of the typing. So here it is, bonds. Which type of bonds we have? We have two bonds. We have two types. You said we'll not go through other bonds, but we have one bond called ionic bonding, correct? So here it is. And the other one is called covalent bonding. So, and we have seen the definition. Ionic is combination of a metal, nonmetals. Combination. So combination of a metal with non-metals. Here we have a combination of non-metals. Let me get here. Combination of non-metals only. So let me give an example. If I have an example here, I'll put an example here. Example here. So I'll put an example. One of the examples here is the simple one is, I apologize, sodium chloride. That's an ionic compound. We have sodium is a metal, correct? And here we can say we have H hydrogen, and then we have, it's a tab war, so this is a covalent bond. Both are oxygen here, I apologize today. So sodium is a metal, correct? The chlorine here is non-metal. So here we have hydrogen is non-metal. Hydrogen is non-metal. And we have oxygen is non-metal. So you can see now from the name of, from the structure of those compounds, the ionic compounds, they have to have a metal. They have to have it. The covalent bond, they should not have any metal. Otherwise, there will be the name will be considered to be ionic, correct? Ionic bond or ionic compound. So sometimes just we say bonds or compounds mean the same thing. So now let's look one at the time. We look from here, and let me just close these definitions here and come here and then look at the definition of a covalent. With the definition is there, but we will see how we can name those compounds or those bondings, the covalent and ionic, and then we'll make some examples. So let's look at this. We'll start with ionic, for example. Ionic bonds or bonding, same thing. So let's look at this. What's ionic bonding? How we name this compound? So we'll start here. It's called naming ionic compounds. Now, naming ionic compounds, we can have synonym for that. We'll say ionic compounds nomenclature. So ionic compound nomenclature. If you see a nomenclature means naming. So the word nomenclature means naming. The word nomenclature means naming. So ionic compound naming or ionic compound nomenclature. So this is the same thing. So how we name this? Well, it turns out to be, let me just change the color so you can follow me here. You will have to start with the metal name first. Start with the metal name first. With the metal name first. Then the non-metal name will follow with ending of IDE. So IDE. So IDE, it's in red here. So IDE. So, and then underline it. So we need to end up with the ionic compound will end up with IDE. Now, sometimes the non-metal, we have to work on the non-metal to get to the non-metal adjusted so that it will accept the IDE. So is here. The non-metal here should be adjusted and then the IDE is added. So let's look at the name of this, NaCl. That's an example here. So zoom down. Example here, guys. So this is the metal is Na. Na is sodium, correct? And Cl is chlorine. So here's the adjustment we'll have to do. Sodium will not adjust anything else without adjustment here. Is here? No adjustment. Use the name of metal as is. Correct? So that's one. So we'll not touch the name of this. Here we have to do, here it is with the chlorine. Adjustment is needed. Correct? So we'll have, instead of chlorine here, we'll take this one here. So here it is. The chlorine here will be, I will take the I and E out. So I will go ClOR, and then the in red here, the I and E, I will strike it out. So this one here, out. So here it is, and I will strike it out. Here it is, guys. The chlorine here, I strike the I and E out, and this will turn to be what? Chloride. So chloride. So I added the IDE here. We just highlight this one here, guys, for you. Right. So the name of this ionic compound is sodium chloride. So the name of this compound is sodium chloride. So the name then will come. So final name is sodium. We did not touch, and then sodium, and then one more here, chloride. So everybody's following me here? So this way here, we have all these names, so we can all the time adjust the non-metal one, so it will fit. So let me give you another examples. Let's have another example. So another example. We'll have a couple of those examples here. So here. So another example, I will say I have magnesium, Mg, and then I will write in front of magnesium, I will write this one here is 3. Come back and look at those subscripts again. Magnesium, and then I'll put in front of the magnesium here the correct. So this is, and this is phosphorus. So I have 2 elements. One is metal, one is not non-metal. So the one will not have no adjustment here. So we'll have magnesium, Mg. This is magnesium. Okay. Now, if you look at the P here, this is phosphorus. So this is phosphorus. Oops, phosphorus is US. But it's, anyway, so phosphorus. So this one we need to do adjustment. Our adjustment here will be, we'll adjust this one here. Take the phosphorus as is. You can see me here, and you'll see the adjustment you will need to do is take the phosphorus out, side, and then take phosphide. So you take OURUS out. So this one here will be out, and then will be red, so you can. So this one is out, and this one will be then will be turned to be. It is phosphide. So I took all the OROUS out. I added IDE. This is magnesium phosphide. Magnesium phosphide. Magnesium phosphide. So another example. We'll do another example. Okay. How about we'll do AL subscript 2 O, and then we'll come back to look at those subscript, why they are like they are. Just time being, let's look at this. So Al is aluminum, will not touch it, will not touch the aluminum. So this metal will not touch. So this is aluminum, and it's not touched. And O is oxygen. So aluminum and oxygen. So what we have to do with the oxygen, we have to readjust the oxygen again. Adjustment, we need adjustment for those non-metals all the time. This will be oxygen, and this one will be turning into, copy this one here. This one will be base into this one here. GEN is wiped out. I'll strike it out here, and then I will have, so this one here in red. Okay, so this one here will be an IDE, oxide. So oxide. So I have added here the IDE. So I took this one here and I put this one here to be oxide without the Y. So I take the Y too. Yeah, without the Y. Yeah, so you can see all those here without the Y, oxide. Another one, maybe. Another one. We'll take another example here. Another example we'll take with nitrogen to see how the nitrogen will be working out. So we'll take calcium and then subscript, and superscript, subscript 3, and then N. So it turns out here we have calcium will remain as is, no touching, no adjustment, no nothing, just calcium. Okay, so nitrogen, this is nitrogen. So we'll have to adjust this one here, nitrogen in nitrogen. So we'll take the OUGN, this is the 4 alphabets out. The same thing we took all those here. This should be backed out. So we'll take all those 4 out. And so this one out, and this one will be, somebody will tell me what will be the whole thing is, will be, copy this one here, will be, I'm pasting it. What's the name will be? Nitride. Nitride. So let's look at the tab one here, magnesium phosphate. So the name here, sorry, magnesium. First, let's go back and name this compound. It will be magnesium, magnesium, and then just phosphide. Okay, so that's the first one. Then the aluminum here will be, the name of this one will be aluminum oxide. Correct? So aluminum oxide. So example, we took another example, and this one will be then calcium nitride. What you have to know, to note here, that's the nitrogen, the nitride, it's not capital letter. The N is from nitrogen, it's not. The capital letter just for the first metal. For the first metal will be, that's only for the first metal. And all the other ones inside are small letters. There is no capital letters in both. Just, but I put it there, capital letters to show you here. So now, maybe another one, and we'll take potassium, correct? K, another example here. Okay, so we'll take potassium, maybe another space. Take potassium, and then we'll take another element with it. So potassium can be either or we took calcium. Let's take barium, not barium, and then 2, it is C, and subscript of 2. So what we name this one here? The metal will not change anything, correct? So therefore, the Ba is barium, the second group. If you look at the barium, the second group, underneath the strontium, barium, there's no change, nothing there, as is. The C is, somebody will tell me what the C is? The C is carbon. So we have to do adjustment for carbon, and we take here the ON out, correct? So we take this one ON out and we strike it out. So, and then we'll say, okay, copy this one here. This one will be carbide. So this one called carbide. So the name of this then will be barium carbide. Please make a note. That's the second, the non-metal will start with the, not capital letter, small letter. So carbide, C, the C with the small letter, not capital letter. So see all those, the only capital letter is for the metal. The metal, because start the whole naming. So with all those examples, I gave you the formula, and you have to tell me what is the name of it. So all these examples here, correct? We'll say now we have 2 ways. This 2 ways to approach the nomenclature of the ionic, as well than the ionic ionic bonding or compound. That's not it's the same thing. Ionic compound, nomenclature of ionic compound. So the first way here, we mention it. What I gave you here, I gave you the first thing here, I gave you the formula and you name. So the first way here, first, now no capitalize now, just the structure is given, the formula, the molecular structure, okay, is given, and the name of this formula is asked. As I said, I apologize, it's slow, but I came up with a lot of ideas, but this is the best idea because then I can post this one here as well as Microsoft Word or PDF too. You can read, you can hear, you can go through the writing right up here because this Stella is not working with Webex. Webex is not friendly, so Zoom is much better. Zoom does have and Teams, they do have whiteboards. Webex took them out. I don't know why, but in the past Webex did have the whiteboard, but now our whiteboard is made up for Microsoft Word and our own typing. So if there's a whiteboard, it would be very nice to write on with the stylus. Anyway, so this is the first thing here. Now, how about if I will give you the opposite of this? So it is, I'll copy this one here, and then I'll go here. I'll say number 2. Number 2 here, not 1. The is given is the name. So given is the name of the ionic compound, and asked is the formula, and asked is the formula. Take this one out. Okay, guys, so the opposite. I will give you now the ionic compound, correct? The name of it, and you will have to come up with the formula of it. So, well, this is a little bit difficult than before. So this approach here, this method needs to look into the charges. You have to look into the charges of the metal, charges of the metal and non-metals. So you have to look at the metals and non-metals charges. So how we do this? So inside your icon, inside your PowerPoints, but I'll give you one from the web. Let me go and give you one from the web here, and it will be, I think, much. So periodic table with multiple charges of the elements. So let's look at this, guys. So now, is this topic coming in the final exam? Yes. Is this topic will come in the quizzes? Yes. And if you go even for 12, the second part, this type of naming will come after you. And even if you go organic, nomenclature is part of the backbone of chemistry. Naming compounds is the backbone of chemistry, whether we like it or not, but that's, we have to learn it. We have to know how to use it. So here it is. I'm trying to get, let's take images here. Maybe you get good image with all the numbers. I'm trying to get the one that have 4. Okay, this one here, this one is good. Just bear with me here a little bit. So the one that have all the charges. So how about this one here? Let's see here. Yeah, this is very comprehensive, but I can't. Yes, that's a good one. This is a good, very good one. So let me see the source of it. Now, copyright of this, we are allowed to, as long as we don't make a profit. Just for copying to even with copy machine. As long as you don't make any profit. If you make 1 penny, the author can go and charge you a couple of thousand or millions of dollars in damages. So, but as long as it is for the sake of education, there's no copyright. So I'm copying this. Remember the snipping tool? That's free. A couple of years, 20 years ago, it's about $45 or $50 worth. Now it's part of the Windows, so I don't have to pay $20. So then I go edit, copy. Guess what? Put it here. So here it is, guys. And I'll paste it. And I can even extend. Let me go look the layout here. Maybe you can get the margin here. Maybe 0.5, see what will happen. So now we have this one here. We can expand it here from the edges. And we can go further here. So you can read. Now, you can even go further here so you can see it much better. So I think, okay, so I think that's enough. So what's happened is group number 1, if you look at this, group number 1, it has +1. So if you look at this group number 1, all the charges is +1, +1. So all those are +1. Group number 2, 2A, is 2A here. 1A is +1. Group number 2 is +2. Those are the metals. The metals, they have to have positive charges. Metals do have what? Positive charges. Then all the transition elements, we have a problem with them. So you will see iron has iron 3 up and iron 2. Chromium, you have chromium 3, chromium 2, and we have even chromium 6. So, and you can see this, those are charges we really need. Now, when it comes to the nonmetals, the nitrogen is always 3-, correct? So if you look at the group, 1, 2, 3, 4, 5. Group 5, the nitrogen group, 5A, 3-. Oxygen, 6A, 2-. The halogen, 7A, 1-. The heliums and the inert gases are 0. 0. Maybe another one will give us easier part. This one is easier part. You can visualize the whole thing here. This one's easier. Just it's not comprehensive like the one we have, but yeah. So let me take this one here as well. New, and I'm cutting this one here as well here, or maybe make it very smaller here so we can expand it more. So and then edit, copy this one here. I copy it into the home, and then I will paste this one here. So, well, it came up in the top of this. That's fine. Anyway, so you can see that's the simplest one. We can visualize the colored one. We can visualize those are simple ones. But if you go for comprehensive one, we have to look into the whole thing, correct? So now let's look at some of the examples here. We will name some of the, I will give you this, the name of it, and you write for me the structure. So Here it is, guys. Aluminum, correct? That's an example here, guys. So this is aluminum here. I think here's the example here, guys. Go back and forth with those tables here. So aluminum, and then I will say aluminum, just one metal. We don't use polyatomic, but just one metal. We'll say aluminum fluoride. So now write, it is, write the formula, correct? The molecular structure or here molecular structure of the ionic compound below. Ionic compound, the ionic compound below, and I have to have this one here. So we have aluminum fluoride. How do you write the structure of aluminum fluoride? Well, I say if it is the case like this, I have to put them like this one here. So here it is. Aluminum is Al from the periodic table, and from here you can see Al. The atomic number is 13, correct? This is Al. Well, Al carries what's the charge on it? Group number 3, what charge on this? Aluminum carries the charge. What charge is this? Positive 3. Perfect. Positive 3. So let me just highlight this one here, make it bold, and make it red. Correct? And then fluoride, because we have readjusted the name from fluorine. Fluorine here, on the other hand, F carries the charge of, it is the charge of here. Now look at this. Group number 7, what charge fluorine does it have? Whether you go up or you go down, whatever you like. Which one? Use the smaller one. What group number 7 have? All of them. -1. No, not 1. -1. Remember that the metals are positive and the non-metals, they negative. Means the metal is giving away its valence electrons and the non-metals are accepting those electrons. So it is, so this one here is -1. So I'll make it bold. Here, guys. Bold. And then -1. So what I will do here, I will have to write Al, and then I'll put subscript on Al, superscript, 3 plus. 3 plus. So I'm putting here Al, and then put in front of it 3 plus, and make space between the 3 and the plus. So here it is. Make it bold, make it red, and maybe to see it much better, maybe I'll explode this one into 18. So take this one out, and then I'll write the fluorine, correct? Fluorine here. Fluorine, make it fluorine, and then here superscript. Which number I have to put? Just copy and paste this one, correct? So I'll put, yeah, I put here, it is superscript 1 negative. So I'll put this one here and bold the whole thing, and 18, and then put it in red. Now, looking at the whole thing here, take this one here out. So when you have this one here from the table, from periodic table, the charges with multiple charges, you have to swap. The next step is to swap those number of charges. Swap those number of charges. So the next step is to swap these numbers, but not the charges. The plus and minus, no positive or negative here. Just the charges. So I will say if that's the case, I will take this one here, copy this one here to show you. So here it is. Paste this one here, guys. So I'll take aluminum here. Okay, so trying to see if we can get the one of the shapes here. So sure if this will work. Okay, it's working. So take this one. No, that's the opposite here. Take this one here. Insert. Okay. So I'm taking this one with the aluminum. Okay, guys. And then I say fluorine here. Fluorine here. Then I will have insert. Okay. Trying to get this one here, maybe. Here. So here. So okay, guys. So this one will be AL subscript 1, correct? And take the subscript out, and then F, and then put the 3 here. So the subscript, a subscript. So here it is, guys. So this is the structure of aluminum fluoride. The one is understood but not written. So the one, if you look at this here, the number here, another color. The number 1 is understood, but it's not written, but it is not written. So if you look at this, so aluminum fluoride, then here it is, will be looking like ALF3. So let's look at this. This is, yes, hold on. Let's put this one here. This one, yes, any question? Yes. No, we'll not take the charges. Charges are not part of the swapping. We swap only the values. Yes. No, we'll keep this one by themselves. I'll show you how to verify this. We'll swap the numbers, but no charges. We'll not take the positive here, I say, but not the charges. So here it is, and put this one here underlined. So we don't swap the charges with them. Now, if I look at this, aluminum is 1, correct? So calculate the whole, and it's a neutral compound. So it should come, aluminum fluoride has 0. So the charge is here. It is AlF3 has the sum, the total sum of 0 charges, and it is a neutral ionic compound, correct? So now let's look at this. I have 1 aluminum plus 3 fluorine out of this structure, correct? So this one here, let's look at this one here. Here it is, guys. So copy this one here and then come here and then look at this, guys. Here it is. So then if you look at the charges here, out of the table here, 1, and the aluminum, how much it has? It has positive 3, correct? And then plus 3 multiply the fluoride ion has minus 1. So if you add this up, will be 3 minus 3 and will be equal to, will equal to 0. So total charges is 0. So this way we can verify, correct? We can verify. Now, we call aluminum as a cation. Aluminum is called cation. So aluminum, now it has a name. So here it is, Al, called aluminum metal. Aluminum metal, correct? Capital A, aluminum metal. So, but Al3 plus called, it is, copy this. It is called Al aluminum, it's too large here. (14) and okay, so aluminum ion and or called cation. So this is a cation. So now we define what we mean by cation. A cation is an element, correct? So it can be even non-metal. Non-metal can be a cation, correct? So it's an element that lost some of its outermost electrons. It does really lose some of its outermost electrons and will appear positive. So what do we mean by cation? Let's look at this. Cation is an element that has lost some or all its valence electrons. So we are now defining something new for us. We have cation definition. Anytime I have a charged, so we call this one cation as it is equal charged element. So this is element here it has a charge on it. It's not neutral. So it is positive charged. So okay, guys. So it is what? It is positive charge. So it is positive charge, correct? So that's what we call it, cation. We call it what? Cation. And the outermost valence electrons, those are electrons. We'll come back and look at this one here. Valence electrons are electrons that found at the outermost shell in the outermost shell in the atom. Okay, guys. So this is a definition. Now let's look at the what? At the negative charge. What we call the negative charge. Well, it turns out to be we will have a definition here as well. So let's take this one here. We'll copy it and then we'll go here. The fluorine here, on the other hand, is called fluoride ion. So I have to take it out here. Fluoride. So here it is, guys. And so fluoride ion. And it has a name for that. It's called anion. Anion. So anion, those are by definition, are elements charged with negative charge. So here it is. So we'll take this one here. Copy this one here. Copy. So what is an ion? An ion here. An ion is just copy and paste charge element, and it is negative. It is negative charged or negatively charged. So whatever. So negatively charged and is positively charged. Positively charged. So positively or negatively charged. So now the ionic bond, it has unique type of structure. So we can have two ways of naming them. One way in the exam, if you see the final exam, NCS exam, they will give you the structure and you name it. Well, one time they will give you the name of it and you have to write the structure of it by multiple choices. So now, this is until now straightforward. We have a problem with the transitional element. There is always a problem, transitional element. So we did not add anything about this, but when it comes to the transitional elements, which are those here from, you look at them from 3 to 12, group 3 to 12, those have multiple charges. When anytime we have an element that, or metal that has multiple charges, you have to add Roman numbers. So let's put this one here. This is one of the very important stuff. You will go 12 with the same thing. They will come back to you. So here it is. As a matter of fact, ACS exam for 12 put a lot of emphasis on the CHEM 1211. So now, how about metals in periodic table that have multiple charges? How we name them? So such as, I'll give you one as an example. Chromium. Chromium here, which is Cr. So chromium is very unique. It has About two or three, I think. So well known. Chromium start with no charge. No charge is 0. So 0 means no charge, not a cation. That's no charge here. So this is not considered, but at least I gave you cation Ca. Sorry. Here it is. So then you come here and then put chromium here, and then you put plus 2. Again, all the metals, they are positively charged. Here, make sure that you understand here. Maybe I put it all the way at the top here somewhere. All the metals are positively charged. Where we did discuss the ions, I think I put it here. Here it is, correct? So I can put this one here before all metals are positively charged, and all the non-metals are negatively charged. So this is a note. Note. And then I'll just this one here red, and then bold it for you. So this is very, very important to know that all the metals are positively charged. You cannot have a metal negative charge. You'll get a Nobel Prize for that. I mean, if you can prove that the metal can be negative, this will be a big discovery. But metals are not accepting. They give away their electrons easily. Non-metals, they take in those electrons. So chromium has 2 positive. So I can write 2 positive here. It is as in the as here. Chromium has 2 positive, and it is chromium near manganese and vanadium. So it's 3 plus. So write it here. Then I'll add this one here, 18. So I'm bold the whole thing. Here it is. Here it is, guys. So bold this one here, make it 18. So this is one of the chromium here you have, and this is chromium called chromium 2. This is, you have to give it a name. So use the Roman numbers, correct, to express the values. Let me just put this one here smaller. 15. The values of the charges. So charges. So here it is. So this one here will be called. So this one will be called copy paste here, and this one will be called, guys, what's the name of this? Chromium 18. This one here called chromium, and guys, 2 will be the Roman 2, correct? So you understand what's the Roman numbers, correct? Everybody understand the Roman number? Yes? No? Okay, so so this one here, chromium 1, chromium 2, cation. So if you look at this, that will be just the Roman number, just Roman numbers. Here they are, look at them. Okay, guys. So this is 1. This is 2. This is 3. Now, watch out for 4. 4 is different. So the V is 5. In your left, that's -1. In your right will be what? +1. So the 4 is 1 negative and then 5. 5 minus 4 is 4. So this is, it is equal 1. This one here equal 2. This one here equal 3. This one here equal what? 4. Correct, guys? Just to know. Now, how about 5? 5 will be just V. So V here, number 5. Number 6, you will add then 1, 1, 1, 1 until 10. Correct? So then let me see here. V1, this is 6. Correct? V equal sorry. Then you have 2, 2, that's 7. I added 2 lines. 1, 1, I add 2 ones, that's 7. Correct? Then V, and then 3 of those, 1, 2, 3. Correct? That will be 8. And now the problem now with 9. The same thing with number 4, we have number 9. Number 9 turns to be 1 in the left is minus, correct? So 1 in the left, and then X. X is 10. So this one here is 9, correct? 10 is X. So 10 is, that is 10. So now we'll ask, how about 11? Well, X1, this is 11. Not 1, sorry. Not the one we know, that's it's like an I. Correct? So 12 will be X1, 1. That will be 12. Now, and etc. So how about this number here, guys? Now, just practice. Practice, okay? So how about this number here? X, and then this number is equal to what? But they'll tell me? Come on, guys, don't let me down. Okay, so we have 1, 2, 3, 4. We have 40, correct? How many X's? 40, correct? And then the 1 is coming on the right hand, there will be 1. So the answer is correct, is 41. Make sense, guys? Okay, this is 41. How about if I will say, now let me see here. Let me see here. 1, 2, 3, 4, 5, maybe 6, 7. Then put 1 here. 1 here. What number is that? 69. Okay, let me see how many X's we have. 1, 2, 3, 4, 5, 6, 7. We have 70. X 70. Since the 1 in the left is -1, will be what? 69. That's correct. So you get the idea? And you tell your kids, don't go and look at the XXX, the 3 X's material, correct? Is verboten. It's not allowed. In German, it's verboten. It's not allowed to watch for the kids. I mean, small, tiny kids watch XX rated movies, correct? So the XXX is how much? 30. So I think by the time they met XXX, those are designated movies for a person is 30 years of age. Are you following me here? The X, the three big X's, are not allowed for the teenagers or under the minors. But at least you get the XXX, that's 30. So they are really designed for people, adults with even not in the 20s, only for 30s and above. I'm close to 70, by the way. Anyway, so you get the idea how to now to do those. And that's the same thing, the idea of the XXX came from the Roman number. And that idea is those are good only for 30 and above of adult, but then whole thing changed. Now minors, they have phones, they can't watch anything, everything is open, but anyway, I'm not saying anything, no comments. Comments on that, but here it is. Now, we know now the Roman number, because that's very important to know those numbers. Because when it comes to naming, you have to add them. When it comes to multiple charges of those elements. So now we have chromium 2 and we have another one, chromium 3. So here it is. That's 3 here. And guess what? We have chromium, let me just paste this one here, 6. So the 6 is not in the table because too many. So look at this. So this one will be just, you tell me what the number will be here. So here will be what number? Chromium what? We have to add what here? Another number, correct? So another number, that's chromium 3. How about here? This one is 6. How about 6? Somebody will tell me. 1 and then 5. If that's the left, that's negative 1. So 5, 1 minus 5 minus 1 is 6. So those, what's this? That's 4? Oh, 6, sorry, that's 4. I'm sorry. That's 6, yeah. I thought 4. Well, there is chromium 4, but it's not stable. Now, I can show you that some of them is that's chromium 6. Now we have manganese, which is very unique. We have time? Yeah, we have still time. Good. Manganese is very unique. Manganese is Mn, correct? This Mn is very unique. You'll not find any elements that really carries out that many charges, which really stable. I mean, it's manganese. The A instead of V. Manganese and Mn, it has, look at this. It has Mn first, no charge. No charge means 0. Mn, it has a 0 here. We'll carry this one to 0 here. Here it is, guys. 0. So no charge here. It's manganese metal. So metal, and it is no charge. Okay, so then what we have? Let's go further. It is. I'm copy this one here and paste it in the bottom here. Manganese, and then I have. You'll not believe it. This is very unique situation with this manganese tab of 1. Here it is 1. Let's look at how many multiple charges. Here it is, the first one here. This is +1. Okay, and then make copy of the whole thing, and then it goes further. So copy, paste, 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 paste. So and paste. So this is manganese 1, manganese 2, manganese 3. All those are stable ions, believe it or not. So 4, manganese 5, manganese 6. I will add another one, which is very stable, one very aggressive, makes stains on the clothing, so very strong oxidizing agent. So we have how many? The metal was 0, we not considered, but we have 7 of those. So let's put the name of this will be, this one is manganese, and then just one, correct? Just one here. This is no S here, sorry. Manganese 1, manganese E here, manganese 1, and then let's go for further here. Copy. Copy. And copy here. That's the reason I want you to understand of this Roman number, so you can understand those elements are there. So this is 1. This one will be 2. This one will be 3. Correct. This one will be 4. This one will be 5. This one will be your 5 and 6. This one here will be your 5, 7. So all those are cations. Cation, then you add just the word cation. I'm copying it for you guys. So you can see those are multiple, they come in multiple, so okay guys, so when it comes to naming those compounds, I mean, I'll give you the name of it, and you have to tell me what's the name of it. Let's look at an example here. Let's put an example here. I'll put some examples here. Change the color. So example here, guys. Let's put an example. I have you. I'll say write the formula. I'll stop in 2 minutes. In 1 minute. Give me 1 minute. Write the formula structure of manganese, manganese 4, manganese 4 phosphide. Phosphide, sorry. Phosphide ID. When we come back, I'll stop here. When we come back, we'll come Monday. We'll know how to name this, and then we'll go for the covalent compounds, how to name, and then that will conclude the whole chapter. Correct? So I hope that will help. I'll upload this stuff here to you. I'll upload it for you guys. Save it as. Covalent and ionic compounds. Yes. You can see it should be there. The one is not there. I'll look at it. Yeah. Chapter 1. Yeah. Chapter. Yes. I said you don't need the book. Why you take the book? Oh, you're online, but you don't need the book. We have ebook for free. Yeah, you did not see the announcement. Yeah. Okay, you can. That's fine. Yes, you don't need the book. You don't need the book. And you don't need it. Assignment. Well, you look at the examples you have. All the examples you have there. You look at the ebook. Not the ebook. Go to the announcement. See that where is to find the ebook.